Professor Micheli from the Department of Computer Science of the University of Pisa. I am the coordinator of the Computational Intelligence and Machine Learning Group with more than 20 years of research activity on artificial intelligence and machine learning. I'm also the national coordinator of the Machine Learning and Data Mining Group that include more than 40 research groups within the Italian Association for Artificial Intelligence. My group work for basic and applied research on machine learning, including the neural networks, reservoir computing, kernel-based approach, generative probabilistic approach, and deep learning. Here you can see on the right a list of applicative areas, but I will show there later and by example and instance for them. So we can skip a specific field of research activity is about learning structure domain. That means sequence, trees, or graphs. We pioneered since more than 3 years ago again the development of new models in this field, and we have an international leadership indeed in efficient deep learning for structure domain. Another interesting field is the intelligent sensor network. That means basically merging machine learning and the Internet of Things. I will show you later some instance of that project. We have a long-lasting experience in interdisciplinary application, especially for biomedical and life science, chemistry, engineering, and other. I will show you. So skipping this, let me make just a short premise about machine learning. This scenario is that we have a growing ability and need for analysis of empirical data. We have a central methodological role of machine learning due to the changing of paradigm science that is more and more data-driven. So we have to consider it's difficult to provide adaptivity intelligence just by programming. And for this explains the reason for which machines that can learn from data are the only choice to provide intelligence to the system. It's not a love story, but it's just the only choice. These open huge application areas and opportunities, but also there is a need of open data. We can look to the bioinformatics example, that is a positive example where there are open data that you use. We have to consider it for the healthcare case. We have seen this morning a lot of issues, but in my opinion, this is my opinion, there are still more benefit than issue. I'm an optimist. Okay. The second premise is about complex data, because I anticipate traditional machine learning deals with vectors, this form of representation, but you can see in the picture many interesting cases of structured data like temporal stream or time series, proteins, small molecules that are graphs, or biological networks. So many instances that are interesting for the biomedical fields. See, this is just a rapid overview about our application area for our group. So, but today I will explain just on the left part for chem and bioinformatics, human activity cognition for healthcare, and intelligent sensor networks. So the first example is about a European project that was called the Rubicon. Our activity was about the study of a distributed neural network for robot ecologists that you can see in the picture. I hope you can see because it's quite small projection. And we started ambient assisted living, an hospital demonstrator. You can see in the picture below an example of human activity recognition, where the models is able to recognize for the user that is she's going to make an exercise, or she's relaxing, she's making sleeping, or whatever. Okay, so during her life. Another instance was about another European project, the Doremi project, where the aim was the promotion of a systematic solution for healthy aging, managing a lifestyle protocol. Our activity was about the development of neural network models for human activity recognition from sensor time series, so about recognition of behavior pattern for medical purpose. It's interesting that here the studies was about daily monitoring modules for parasite with 36 installations in real apartment in UK and Italy. So to dealing with real people, it's not so easy. Also, for instance, models were developed for physical activity expenditure estimation or balance schemes estimation. You can see in the picture below an example of ambient with some environment sensor, a balance board, a bracelet, or whatever. Okay, and of course the doctor that can read this data. This is just a zoom about the physical activity expenditure estimation, just to say that we were able to tune the system for elderly by the machine learning, and we were able to dramatically improve the accuracy of commercial device about more times better for commercial device, because they are tailored to elderly people, and just not the standard that are probably tailored for young people making sport or whatever. Okay. So I will not go in detail anyway. Also, I can skip this one about balance skill to stay in time, but you can have the slide. And this is a completely different experience about neonatology. The aim was about early estimation of a mortality risk for of very preterm infants. We started from features such as birth weight, gestational age, sex, and other physiological variables up to 12, measured in the first minute after the infant's born. These allow to help doctor, okay, you can see the instrument on the left, so it's just an instrument, okay, it's not that provide the solution. Help doctor in decision for immediate therapy when you need to decide in a few minutes, and to better advise the parents and so on, okay? What's interesting for me is that the dataset has more than 28,000 of infant records collected from the Italian neonatal network, and this explains the relevance of an open data approach that completely makes a difference. Of course, if you have 100 of data just retained because you are proud of your data or genius, it's different. This is an interesting case, at least from our point of view. We developed a tool that is free to be used, the preterm infants survival assessment predictor. We publish the result on the scientific report of the Nature journal. The other field is about cheminformatics. We pioneered this approach since 1998 for the prediction of chemical properties of biological activity by models for graph molecular data. You can see in the picture example, here the research question is if we are able to predict directly from the structure the property or biological activity of a molecule. And for instance, in this case, if this molecule is toxic or not toxic. Okay, so it's a classification problem where your data is a graph representing a molecule. Okay. This is an ongoing project about cardiology. Just to summarize, the input can be an electrocardiographic signals, and the output can be a Brugada. In this case, the syndrome is Brugada syndrome, the Brugada diagnosis alert. And this is a proposal of project has been submitted for the call of Toscana region about this field. It is a very interesting syndrome because it's not common, but really dangerous. You can see the data is 80% of sudden cardiac death due to this syndrome, especially in young people. Okay, so it's quite interesting, at least from our point of view. Just a few words about didactics that is important for the future, not just future generation. Thank you. And so at our department, we have an introduction to artificial intelligence at the undergraduate program in computer science, and the new master in computer science have a specific curriculum in artificial intelligence. So you can expect a new expert in artificial intelligence for the next year coming from the University of Pisa. I have to say they are coming with a very good steam. So second degree is the exactly laurea magistrale. Is a translation in English. Of course. This is just a call for participation because we organize each year the machine learning and data mining workshop within the international conference of the Italian Association for Artificial Intelligence. It's the national reference meeting in this field. So if you have an interest, please send to me your reference for an invitation. Yes, we are open for new projects. Take home message. Keep in touch for developments, and for questions, please write to me or ask here. And we wait your question.
Thank you very much.